Hi everyone, my name is Jasmine, and in this project, I built a machine learning model to predict the electrical energy output of a combined cycle power plant. So we have 9,568 hourly observations, and for each hour, we know four ambient variables. They are AT, which is temperature in degrees Celsius, V, the exhaust vacuum, AP, the ambient pressure, and RH, which is relative humidity in percentage. So our goal is to predict PE, the hourly electrical energy output in megawatts. Since PE is continuous, this is a supervised regression task. So as you can see, I loaded the data set in Python using pandas and confirmed there were no missing values. Um, my features are the four ambient variables, the P and P is a target. So for evaluation, I use three standard regression matrix, which are R squared, RMSE, and MAE respectively. To ensure proper generalization, I split the data into 6% for training, 20% for validation, and the rest of the 20% for test. And I used five-fold cross-validation on the training split to check model stability. I implemented everything in a single sprint, as you can see. I compared several models, but the two major ones were the linear regression as the baseline and random forest regressor as a nonlinear ensemble model. Let me show you. Yeah, as you can see over here. So I also briefly evaluated decision trees, gradient boosting, and KNN. For random forest, I did a small grid search over 3 count and depth using fivefold CV with negative RMSE as the scoring matrix. So here is the test set performance. For the linear regression, R square is around 0.93. RMSE is around 4.51 megawatts. MAE is around 3.60 megawatts. As for the random forest, the R squared is around 0.96. RMSE is around 3.37 megawatts, and MAE is around 2.45 megawatts. Across all matrix, random forest performs better. So I selected it as my final model. So the scattered plot shows the predicted versus actual P on the test set. Most points lie close to the diagonal dictating strong predictions. So the final test matrix are the final test so it's the final test matrix are R squared is 0.9609, RMSE is 3.37 megawatts, and MAE is 2.45 megawatts. Given a plant produces an average of 454 megawatts and RMSE of 3.37 megawatts means a relative error of under 1%. The residues are centered around zero and fairly symmetric, suggesting no systematic bias. For feature importance, random forest shows that AT accounts for around 90% of total importance, followed by V, RH, and AP. So to summarize, I framed the task as a supervised regression problem. I compared several models using a train, validation, test split, and fivefold CV. Random forest gave the best performance with R squared equals around 0.96 and RMSE around 3.37 megawatts. The model generalizes well and provides interpretable insights, especially the dominant impact of temperature. So I would say if I had more time, next I would include tuning more hyperparameters, adding engineered features like time of day or seasonality, and deploying a simple dashboard to track the predictions. And that's all for my presentation. Thank you all for watching.